Right. Hello. So in this video, we will apply the concepts on the proportionality videos to answer these types of multiple choice questions. So I've taken multiple choice questions from past exam papers. If you have not already done so, please go through the proportionality videos and then come back, and for each question, please pause the video and try it by yourself using the methods that are highlighted on the proportionality videos. We use those methods to answer these types of questions and then continue to see if you got it right. So I will go through all of these questions, but please first pause the video and try it by yourself and then continue to view my solutions. Right. So let's start with question 1.2. Mass of an object on Earth is represented by x over g. Which one of the following represent the mass of an object on a planet that has twice the mass of Earth and half the radius of planet Earth? So the quantity that we are looking at here is the mass. Remember that mass is the same everywhere in the universe. So if its value is x over g here on Earth, and then elsewhere it's also x over g. So the correct answer here is B. So the mass of this object is going to be x over g as well, whatever it is. 1.3. Ball A of mass m is projected vertically upwards from the ground with an initial velocity v. Ball A rises to a maximum height above the ground, maximum height h above the ground. Ball B of mass half m is now projected vertically upwards, also above the ground, with an initial velocity of 2v. Ignore the effects of air friction. In terms of h, to what maximum height does ball B rise above the ground? So let me highlight that this is a projectile. So the motion of these objects is independent of the mass. So we will ignore this information about ball B has half the mass of A. So we'll ignore that. So then the equation that will help us to answer this question is the one that relates velocities and displacement. And we have to also note that maximum height. So maximum height there, let me highlight this. Maximum height implies that the velocity there is 0. Okay, so the equation is v final squared is v initial squared plus 2 g delta y, and I'm going to take upwards as positive. That looks odd, right? Let me just put this one there. I think this one is better. Okay, so that's positive. Upwards is positive. So then this is 0, is v initial. So v initial, I'm just gonna insert v there for ball A, v squared, and upwards is positive. Then our acceleration is negative. Put g, h there. The displacement is also positive if I choose upward is positive. So then the height is v squared over 2g. Then we proceed as follows. The height is proportional to the square of the velocity. Okay, so if you double the velocity, if I double the velocity, then the height is going to be, what is double squared? 2 squared is going to be 4. Right, so height is going to go to 4h there. So this 4 is 2 squared. So correct answer there is D. Another 1.2. The acceleration due to gravity on planet Earth is g. Which one of the following represent the acceleration due to gravity on a planet that has twice the mass and half the radius of planet Earth? Equation here is g is equal to g m over square of the radius. So then this is directly proportional. G gravitational acceleration is directly proportional to the mass of the planet and is inversely proportional to the square of the radius of this planet. So then, if I double the mass, twice the mass is doubling the mass, G is also going to double. I'm just going to calculate the factor. Please refer to the proportionality videos if you get lost here. So I'm going to calculate the factor that G is going to change by. So doubling the mass is going to double this G here. And then if you halve the radius, so this is inversely proportional. So halving means 1 over 2 is going to be 2, but inversely proportional to the square. So we put a square there. So that's going to be 2 times 4, which gives us 8. So G is going to change by 8. So the answer is also D there. Two large objects P and R, each with mass M, are placed with their centers R meters apart. As shown in the diagram below, they exert a gravitational force of magnitude F on each other. So let us, before we continue, then we must pick it up that here we will apply Newton's law of gravitation, Gm, M1, M2, divided by R squared. Now what do you do? Let me read this equation first. Force is directly proportional to the product of masses and is inversely proportional to the square of the distance between the centers of the masses. So then I'll calculate the factor here again, that if this mass here is doubled, so the factor is also going to be doubled, and the distance, you double the distance as well. Since the distance and the force are inversely proportional, doubling this is going to be 1 over 2 there, but inversely proportional to the square, sorry. So the force and the square of the distance, so the force is inversely proportional to the square of the distance, so that's going to be 1 over 2 squared. And then that gives us 2 times 1 over 4, which gives us a half. So then we select the answer there is the new force. An object is dropped from the top of a tall building. After time t, the object's momentum is p. What will be the momentum of the object after time 2t? Ignore the effect of air friction, right? So this is also a projectile object. So we will apply the kinematics equations, but those equations do not contain momentum. They rather contain velocity, which is all right because we know that momentum is scalar multiple of velocity. The momentum is mv. So the equation that we will want to select is the one that relates velocity and time, and that equation is v final is v initial plus acceleration, it's going to call it g, times delta t, right? And we can let me highlight also here that the object is dropped. So let us highlight this one here, that the object is dropped. So then the v initial is 0, and the velocity at this time t, so this is, I'm just gonna put that as v, is equal to, this is 0 plus g times t. We read this as velocity is directly proportional to time. So then if I double t, so I double t, then the velocity also doubles. So they are directly proportional. And therefore, if the velocity doubles, now we look at the relationship between momentum and velocity. Momentum is directly proportional to velocity. So if you double the velocity, then the momentum also doubles. And so the answer there is number C. That is our correct answer there. Right. Let's look at 1.3. Two trolleys A and B with masses half m and 2m respectively are connected by spring as shown in the diagram below. The trolleys are initially at rest, so the momentum is 0. Ignore all types of friction. When the spring is released, both trolleys have a momentum of magnitude p. Trolley B moves with a velocity v to the right. The magnitude of the velocity of trolley A will be. So then let us consider the full information that we are given here is information about trolley B. So let's first write the analysis of this problem is momentum is equal to mass times velocity. Okay, so then we express, because what we what we're looking for is the velocity of A in terms of the velocity of B. So then I'll say that this is V is the momentum of trolley A divided by the mass of trolley B. So now we want V prime. If the mass changes from 2m to half m, so what is V prime? Then let's look at the mass. The mass changes from 2m to half m. If the mass changes from 2m to half m, then that basically changes by a quarter. So you've changed the, you've divided the mass by 4, and then you get half mass. So this is the mass of trolley B, and this is the mass of trolley A. So the mass of trolley A is a quarter of mass of trolley B, and velocity is inversely proportional to the mass. So then V prime is going to be, for constant P, is going to be, if you reduce the mass by a quarter, then the velocity will be 4 times as much. So the answer is D there as well. Again, please go through the proportionality videos if you are getting confused. I've covered all of this there.